Hi, welcome to physics lesson. Today we go to chapter 9.1, Introduction to Circular Motion. In our daily life, we can see some objects move in a circular motion. For example, Ferris wheel, and also a lazy Susan, 轉盤啦. In order to describe the motion, we would use some physics term, angular displacement, 角位移, and angular velocity, 角速. Okay, now let's understanding the definition. Now, if the object move in a circle, okay, originally this position, okay, after some time, it moved to another point, okay, so it has moved an angle theta. This theta is defined as angular displacement. Okay, very easy, angular displacement. And also, for the angular velocity, it will be theta over t. Displacement over time is velocity. So W equal to theta over t. W is the label of angular velocity. We call this label as omega. So we have the equation omega equal to theta over t. Okay, for the picture, we draw like this, omega, angular velocity. It has direction. The direction is anti-clockwise direction. For the angular displacement, we will use degree, and also we use another term which is called radian. Okay, radian, here, radian. And we need to know how to change from radian to degree or from degree to radian. Okay, if degree is 360 degree, then we will be 2 pi radian. Okay, 180 degree, it will be pi. Okay, so that means we can change from by proportion, right? So 90 degree, it will be pi over 2. 45 degree, it will be pi over 4. Okay, now I want to know if the theta is 30 degree, what is it in radian? Okay, now please have a try by yourself and pause the video. I will tell you the answer. Okay, now so the answer is 30 degree times and 2 pi over 360 degree, because we can change it by proportion, right? So it will be 2 pi over 12. So it will be pi over 6. Okay, radian. Pi over 6 radian. Okay, but why do we need to know how the angle to be a radian? Because of one equation, S equal to r theta. This is one important equation you have to memorize by yourself, not given in the public exam. S here is called, it means distance. Okay, the distance of the object is traveled. Now suppose P to Q here. So this circular arc, the length of circular arc is the distance of the object traveled is S, okay? Now, suppose the object move for one circle, okay? That means one revolution. One revolution, okay? One circle. That means P would go back to its original position after some time. Okay, so what is the angle here? Theta is 360 degree, right? For one circle, one revolution. So it will be 2 pi in radian. Okay, now by using S equal to r theta, and theta is measured in radian, so we can find S directly. S equal to r theta substitute 2 pi. So S equal to 2 pi r. Okay, can you see? It's the parameter of a circle. Parameter of circle, 2 pi r. And don't forget this equation, omega equal to theta over t. Okay, this is also not given in the public exam. You need to memorize by yourself. Radian per second is the unit. Okay, let me to introduce another term, linear speed. Consider the object moving in a circle of radius r at uniform speed, constant speed, okay? V. This speed V is called linear speed. 佢個線速度is different from angular speed. Okay. Suppose the object is moving in a circle for constant speed. So it has so you move here at point P, you move in a straight line, right? Straight line. Okay, it has a linear speed. After some time, you change the direction. Okay, here. And the linear speed, we use a unit as ms minus 1. Okay, so what is the relationship between linear speed and omega, angular speed? We need to find it out. Okay, we know speed is equal to distance over time. And we have learned S equal to r theta. Okay, S equal to r theta. Okay, now you see theta over t. So do you remember equation? Theta over t will be omega, right? So we can find it out. V equal to r omega is the equation. Okay, three equations, very important. V equal to r omega. So we can know the linear speed after finding the angular speed. Okay, this is the proof. Suppose the object has moved for one circle, okay, one revolution. The time is called period. Okay, now the time for the object to complete one revolution is 1 period. Okay, and we need to know how to derive some equation about period. So period, okay, time for one revolution. So if yes, move one circle, then the distance would be 2 pi r. Okay, the speed is v. So the period is 2 pi r over v. Also, we have learned omega equal to theta over t. If time is equal to 1 period, so the theta would be 360 degrees, so there will be 2 pi. Okay, so t will be equal to 2 pi over omega. Okay, so combining these two findings, we have t equal to 2 pi r over v and equal to 2 pi over omega. Okay, you see many equations you have to memorize. So please divide by yourself and get more familiar with them. Okay, now let's go to some practice. Example 1, merry-go-round. Okay, now we have two ladies here, Amy, Sophie. Okay, are playing merry-go-round. So complete 2 revolutions in 1 minute. Okay, find their period. So what is period? Time for complete 1 revolution. Okay, that's very easy. So it will be 0.5 minute. The period is 0.5 minute. That is 30 seconds. Okay, find the angular speed. Angular speed omega, okay? Omega equal to 2 pi over t. So they have the same period, right? So it will be 2 pi over 30. Okay, the answer is, the unit is radian per second, okay? Find their angular displacement in 15 seconds. So you have the equation omega equal to theta over t. So we have theta equal to omega t. Okay, angular displacement, right? Angular displacement means theta. Okay, for the omega, it will be equal to 0.209, okay, radian per second. So it will be 0.209 times 15. Okay, that would be 3.14. Okay, radian. Express your answer in radian and in degree. Okay, so pi, what is the angle in degree? Pi will be equal to 180 degrees. Okay, as we know, 2 pi means 360 degrees. Okay, find their linear speed. So you have to memorize the equation you learned. V equal to R omega. So for Amy, V equal to, here you see, 3 times 0.209. Okay, for Sophia, V equal to 2 times 0.209. Okay, that will be the answer. And for the linear speed, don't forget ms minus 1. Okay, this is example 1. And try chapter 1 by yourself. You will pause the video and I will tell you the answer. Okay, let's check the chapter 1. It's a clock, okay? Find the angular speed for the second hand, minute hand, and hour hand. So find the angular speed. Angular speed is omega, okay? Omega equal to 2 pi over t. So for the second hand, it will be 2 pi over 60. Okay, the period is 60 seconds for second hand. For for the mini hand, it will be 2 pi over 60 times 60. Okay. For the hour hand, it will be 12 hours, so it will be 2 pi over 12 times 60 times 60. Okay, so we can get the answer. Don't forget the answer should be the unit of the answer should be radian per second. Okay. Radian per second. For part B, find the angular displacement for the mini hand in 20 minutes. So, okay, suppose the mini hand is pointing upward. Okay, after 20 minutes, you'll be here. Okay, so what is the angle? So we know, and the period is 60 minutes. So for 120 for 20 minutes, it will be 120 degrees. Okay, and so this is answer, and we need to know how to change to radian. So it will be 120 times 2 pi over 360 degrees. Okay, so it will be 2 pi over 3. So it will be 2.09 radian per second. That will be the answer. Okay? Question 1. Okay, and then we go to question 2. For question 2, a car is moving at constant speed, km per hour, okay, 40 km per hour. We need to know how to change to ms-1, SI unit. SI unit. Okay, that will be 40 over 3.6. ms-1. Kilo m to m, okay, hour to second. Okay, what is the angular speed? So, omega. And here we have r with v. So by substitution, we equal to r omega, very easy. 40 over 3.6 equal to 50 omega. So we can get the answer here. Okay, 0.222. And puppy, find the angular displacement. Okay, in radian and in degree. Angular displacement, that is theta. So omega equal theta over t. So we have theta equal omega t. So very easy, right? So it will be 0.222 times 15. So 3.33 radian. And you have to change it to degree. So it will be 3.33 times 360 degree over 2 pi. Okay, that will be 191 degree. Okay. Now we go to the last part. Do you think yes, acceleration if the object is moving in a circle? The answer is yes, but do you know why? Okay, now, if the object here moving in a circle, okay, at this point, it has a linear speed, okay, going up, but at some time, can you see? The velocity is changed. Okay, do you know why? Because the direction of velocity is changed. Okay, so there will be a change in velocity. Velocity is a vector. Okay, if there is a change in velocity, change in direction, there will be a change in velocity. Okay, and for the acceleration, there's a definition as change in velocity over time required. Okay, so if there is a change in velocity, that means we have acceleration. So we have acceleration if the object is moving in a circle. This acceleration is called centripetal acceleration， 向心加速。係啦，即係佢轉緊圈嘅時候會向住個圓心去加速。如果冇加速嘅咧，佢就係直去嘅。OK， 因為慣性嘅緣故，佢直去 inertia 直去，係咪？咁而家佢轉咗彎，咁即係有嘢改變佢運動嘅方向，由 net force 改變佢運動嘅方向，咁即係有加速啦，係啦。咁呢個叫向心加速。OK， centripetal acceleration。For the centripetal acceleration, we have an equation here. This is given. Okay. A equal to V square over R equal to R omega square. Okay. And I'm not going to derive this equation here. But for the acceleration, we have two important things. One is the magnitude can be calculated by this equation, and other is the direction. The direction of centripetal acceleration is pointing towards the center of the circle。佢向心加速就係向住個圓心啦。OK 嗱，so please underline，佢向住個圓心加速，咁所以咧佢就會轉彎啦。OK， 因為有個向心嘅力令到佢轉彎。下一課會講翻多啲，會係集中去講呢樣嘢。OK， 嗱 maybe we go to some example。OK， 嗱here a car move at constant speed。OK， find its centripetal acceleration。嗱 here we have v and we have r， so we can directly use the equation v equal to a equal to v squared for r. Okay, so we can get the answer directly. Okay. Now, maybe we try chapter 2. Okay, 2 questions. Okay, so now please pause the video and try by yourself chapter 2. Okay, let's check the answers. Merry go round again, okay? 2 revolution, 10 seconds. Radius is 30 cm, okay, from the center of the merry-go-round. So find the angular speed omega, okay? Find the acceleration a. Okay, so omega equal to theta over t. So 2 revolution, what is the theta? What is the angular displacement? 2 revolution means 2 times 2 pi. Okay, 1 revolution 2 pi, 2 revolution 2 pi, 10 seconds. Okay, so we can get the answer 1.26 radian per second. Okay, for the acceleration, a equal to r omega squared. So we get the answer. Don't forget to change to ms to change to SI unit. So it will be at 0.3, 1.26. Okay, square. Okay, so it will be at 0.474 ms mass 2. Okay, this is the magnitude of centripetal acceleration, and the direction is points towards the center of the circle. Okay. Question 2. Venus revolves around the sun in uniform circular motion. That means uniform circle, and radius is here, linear speed here, linear speed v here. This is r. Find the distance it travel. Okay, for 1 year. Now we have linear speed, okay, and we have time. So very easy. S equal to vt. Okay, constant speed, right? So 35 okay times time. Time is 365 times 24 times 60 square. Okay, so it will be 1.1 times 10 9 to the power 9 km. Okay, that is the distance traveled. Okay, find its acceleration, centripetal acceleration. 向心加速，好啦，咁啊轉圈有個向心加速啊。Okay, a 個 v square for r. So v 35 times 10 to the power 3 and r 1.08 times 10 to the power 8 times 10 to the power 3. Okay, change to meter actually. So we can find out the answer. Okay, that is 0.0113 ms minus 2. Okay. So this is the end of this chapter. And I will suggest you try all the questions in 9.1. Question 1, 2, 3, 4, 5, 6. Okay, please practice them. And this is the answers. Okay, you may download the PDF from the eClass or from the WhatsApp group. Okay.